Hello everyone, now we are in part 2 of chapter 3, circulatory system, blood. Okay, so blood flows everywhere through the human body. We cannot live without it. So it is this thing that is carrying all of the nutrients that we need and also all the wastes. Okay, so within the blood we have oxygen and food, and we also have proteins and cell fragments called platelets that let the blood clot where there's been an injury. So meaning that blood itself, it is an organ. It is just a liquid organ. So what is blood? Blood is a fluid or liquid tissue found in the human body that circulates through the heart, arteries, capillaries and veins within the body. So blood, it is a certain connective tissue, meaning that it bridges the gap between one tissue and another. So blood and blood vessels are always in motion because of the pumping action of the heart. If blood stops, mean that your organs will not be receiving any nutrients, any oxygen. But sometimes during a surgery, you actually need that to happen. And also, if you are bleeding, we actually need blood to stop. Yes, but that's another story. Okay, so blood consists of plasma. Plasma is the liquid part of the blood. Formed elements, these are living cells, red blood cells, erythrocytes, white blood cells, leukocytes, and also platelets, or called thrombocytes. So for blood, it is 8% of your total body weight. Let's say that you're 100 kg, 8 kg would just be blood alone. Total blood volume in an average adult will be 5 to 6 liters, and female will be a little bit less, 4 to 5 liters. So for blood, you look at the color, they are red, but there's a little bit of difference between a blood which is rich in oxygen and bloods which are lacking oxygen. So blood which is rich in oxygen, it will be a little bit much more brighter. Okay, we call it scarlet red. And for the oxygenated blood, it will be kind of deep red, meaning that it doesn't have enough oxygen, so it is kind of dull. Characteristics of blood: the pH will be normal, neutral, 7.35, 7.45. But the temperature is slightly higher than your own body temperature. Usually for your skin it is 36.5. Regular temperature within your body is 37, but blood will be 38, around 38, which is slightly higher than body temperature, and it is heavier than water as much as 4 to 5 times. So blood is for transportation, regulation, and protection. So transportation, it carries oxygen and nutrients to the cells, transports carbon dioxide and nitrogenous waste from the tissue to the lung and kidney, carries hormones from endocrine glands to the target tissues. So what about regulation? So there's some stuff that your blood helps control. First of all will be the temperature. So meaning that it will carry temperature from the hot parts of the body all the way to the cold parts to kind of take away the heat. Water in the blood will absorb heat produced by tissue, because water has a lot of heat capacity, and water also causes the heat to be lost through evaporation, by sweat. So other than that, it also plays a significant role in fluid and electrolytes balance, and controls pH due to the buffering action of the shift. We call it the Bohr effect. The Bohr effect in blood. Okay. Protection. So chlorine mechanism prevents fluid loss through hemorrhage when blood vessels damage. So you can see this when you have any wounds, any contusions. Usually you will not bleed to death. Usually the chlorine mechanisms will stop the loss of blood. Other than that, within your blood you have a lot of white blood cells which protect your body from any microorganisms that can cause disease. Other than that, you also have antibodies. Antibodies will help protect against disease by their reaction with offending agents. So within your blood is 8% of your body, and within the blood 55% will be plasma and 45% will be formed elements. Within the plasma, 91% will be water, and the others will be proteins and other solutes. Within the protein you have albumins, globulins and fibrinogens. For other solutes, we have ions, nutrients, waste products, gases, and regulatory substances. What about the form elements? Form elements are cells. The majority of these form element will be red blood cells, which is 4 to 6 million. White blood cells is second, which is just 4,000 to 11,000. And then you have 250 to 500,000 of platelets. So within the white blood cells, most of them will be neutrophils. Next will be lymphocytes, and then lastly you have monocytes, eosinophils, and basophils. So these are all they only turn up when things really go serious. Okay, so blood plasma. If you look at that bag is full of blood plasma. It is all full of water, protein, and other solutes. Okay, the other solutes meaning that you have nutrients, respiratory gases, hormones, waste product, and ions. So within it, you have plasma proteins. Plasma proteins, they will remain in blood and fluid. They will be there to ensure that your blood is isotonic, because they are all soluble in water, soluble in blood. So it will cause your blood to be isotonic all the time to maintain proper osmotic balance. Okay, so you have three major classes: albumin, globulin, and fibrinogen. Albumin will be the 60% of plasma protein. You can also find albumin in the whites of the eggs. So it is produced in liver. Smaller protein molecules act as carrier molecules for lipids and certain hormone, and it maintains osmotic pressure between blood and interstitial fluid. If osmotic pressure goes down, where does it go? Fluid will move from blood to interstitial fluid, which we will call edema. So the thing is, edema means you'll bloat. So usually, if you look at your limbs or your face will be kind of like normal. But what if your face gets inflated like a balloon, like a ball? Okay, so edema is when you actually have water leaking out from your blood into the surrounding tissue. Usually, you find it if you get stung by a bee. The area will have a local edema. I mean that the area will inflate a little bit. There'll be a lot of water inside. Okay, so if osmotic pressure goes up, fluid will move from interstitial fluid to the blood, and the blood volume will increase. So globulin is 36% of plasma proteins. So you have three types. You have alpha, gamma, and beta. Okay, so it is produced in liver. It is for transporting lipid and fat soluble vitamins in the blood. That's for alpha and beta. But what about the gamma? The gamma are all called immunoglobulin. Immuno means is for immune system. You have GAMED, 5 types, produced in lymphoid tissue, and they act as antibodies which defend your body from any dangerous pathogens. Fibrinogen. Fibrinogen will be 4% of the plasma proteins. They are the largest plasma protein molecules produced in liver. They are for blood clotting. Nutrients include amino acids. Where they're from? They are from the destruction of protein. Where do you get glucose? Glucose from the carbohydrate digestion. And then fatty acids, it is from lipid digestion. All of these are carried in the blood in the form a fraction of plasma solutes. So electrolytes, they have inorganic ions, and they help maintain osmotic pressure and play essential roles in function of cells. Electrolytes also maintain membrane potentials and regulate pH of body fluids. For common electrolytes, you have Na, K, Ca2+, Mg2+. And also for negative, we have Cl-, CH3-, and PO4, which is phosphate. So if you drink 100+ or Gatorade, usually all of these isotonic water would have electrolytes. Mean that when you drink it, you will not feel like you want to go pee. If you drink water just after activities, you drink a lot of water, what happens is that you will cause your body to become hypotonic, so you'll actually urinate a lot. But with isotonic water, because the electrolytes are isotonic to your whole body, so meaning that you will not urinate the water. Gases. Within your blood, there are some gases which are soluble, such as oxygen, carbon dioxide, but carbon dioxide is much more soluble compared to oxygen. Oxygen, usually only 3% of them will be transported as residents of gases. So what are the rest? The rest would be in the red blood cells. Okay, other than that, nitrogen also dissolved in the plasma. And so for plasma, um, if you're a diver, if you go down in beneath the water, the pressure will be higher and the volume will be lower. Okay, what does it mean? It means that the nitrogen that is within your blood will shrink. But as you surface from the bottom of the sea into the surface of water or to your boat, pressure will be low, and what happens that the nitrogen that is in your blood will form bubbles. So these bubbles of nitrogen will collect near your joints. So it will actually cause quite quite painful sensation. Okay, so usually if you wanna surface, if you are under the water, if you wanna surface, you actually have to surface slowly, not suddenly. Okay, okay. So the other thing will be waste products. So you create waste in terms of urea and uric acid. They are waste product of protein and nucleic acid catabolism. They are released in the kidney for excretion. For the cells, we have three type of blood cells: erythrocytes, leukocytes, and platelets. The blood cells, you can see the picture, they are red. Platelets, those are the small things that is around the white blood cell. In the white blood cells will be the larger cells with a lot of lobed nucleus inside. So, what about white blood cell? What about red blood cell? How do they move and how do they look like? They are biconcave discs with no nucleus and with less organelle. So they're much more thicker in the periphery and thinner in the middle. It is so that they will maximize the surface for gas diffusion. Lifespan will be 120 days, which is 4 months. So if you look at the cell itself is kind of like a disc with a thin middle and a thick edge, and they're about 7 micrometers. But they are not actually hard. They are kind of squishy and flexible. They're able to squeeze and bend through the capillaries. So capillaries are small. They're able to kind of stack and then they can squeeze through. So function is to carry oxygen to the blood cell. They are red because of the hemoglobin would have a protein that actually is red in color. In a healthy adult, you have 5.4 million over microliter. For females, it's a little bit low, 4.8 million over a microliter. Hemoglobin has two parts, heme and globin. Heme is pigment containing iron. Globin is protein. In lungs, the heme will combine with oxygen and form hemoglobin, which is oxyhemoglobin. Tissue cells, you have heme minus oxygen, which is called the deoxyhemoglobin because oxygen has been removed. Each erythrocyte would have 250 million hemoglobin molecules. So you have for females 14 to 20 gram per 100 liter. Males we have 13.5 to 18 grams per 100 milliliter. White blood cells is the largest blood cell but few in number, which is 1% of the blood volume. These are complete cells with nucleus and organelles, able to move into and out of the blood vessels into three species, just like amoeba. White blood cell appears to be whitish due to lack of hemoglobin. Lifespan will be live for few hours to a few days. So within your blood, you have 5,000 to 10,000 per microliter. So white blood cell, there are many types: neutrophils, eosinophil, basophil, which is all granulocytes. You can see there's a lot of like small dots within the cell, which is called granules. Granulocyte would be cells without any granules. So within the cytoplasm, it is kind of clean. You can see there's nothing inside. Okay, white blood cells would do most of the work in the tissues. They will use the blood as transport medium. So they provide defense against organisms that cause disease. They can also eat the invaders, phagocytosis. They can produce antibodies. They can promote or inhibit inflammatory responses by releasing or neutralizing histamine. So histamine is this hormone that causes you to have allergic responses. When histamine is released, you start sneezing, you start inflammation. What about platelets? Platelets doesn't have any nucleus at all. They will only live for 8 to 11 days. Normal platelets will be around 350 to 500,000 platelets over millimeters cube of blood. It is needed for the clotting process. So a third of the thrombocytes that is in your body is in your spleen as an emergency store to control excessive bleeding. So the actual work of it is that it will help promote blood clotting and repair the gap between blood vessels. Okay, so if you can see, these are red blood cells. In between them, you have small platelets. So, for platelets to work, it will only work when there is a tear within collagen that is in any tissues or any blood vessels. So, usually when a blood vessel breaks, you have collagen fibers being exposed. It will cause the platelets to become sticky and it will stretch out to cover the injured surface and breach the exposed fibers. The anchored platelet will release chemicals called ADP, adenosine diphosphate, to attract more platelets to the injured area. So more platelets come in and then they will pile up on each other. It will form a platelet plug, which is temporary seal. So this temporary seal will be closing the tear within the vessel around 20 seconds after injury. So coagulation or blood clotting. It is the most effective mechanism of hemostasis. Hemo means blood, stasis means stop. Okay, so platelets will release serotonin to maintain the stimulation of blood vessel, causing the vasoconstriction. The soft plug is solidified through the complex of interaction between platelet membrane, enzymes, and coagulation factors called procoagulants, which is to promote clotting. Okay, so to give your blood to others, you must make sure that your blood and their blood will be compatible. Okay, so we as humans we have 4 types of blood, and then to transfuse to or from each other, we need to make sure that we match or we are compatible. So if we lose blood 15% to 30%, you'll be weak. Over 30%, we have shock. Shock means that your organs are not able to work well. Okay, when your organ is unable to work well, then you might die. Okay, so to actually get or replace the blood that you have lost, you need transfusion. Okay, so the blood type A, B, AB, and O are all because of the antigen. So these antigens are inherited. So this would determine your blood group. So the ABO blood group is the most important blood type system for human blood transfusion. So 50% of the population has either A, B, or AB type antigen. The other 40% would have neither A or B, meaning that they don't have any antigens. They're able to give blood. Okay, so blood group AB, they are known as universal recipients, meaning that any blood type are able to give them blood because they have no antibodies to react with them. A, B, or O can just give it to them because to the AB blood, the white blood cells would think that they are friendly because they have AB. No, the other also have A, B, or AB. So they would just allow those the donor blood to get in. What about blood group O? Blood group O is called a universal donor because they do not even have A or B antigens in the red cell membrane. So due to that, the blood cells of people with A, B, or AB will not react to them. It will just allow the blood to come in. Okay, so if you look at the blood typing, people who are O blood, they can give blood to everybody, but AB can only give blood to itself, but can receive blood from all A, O, and B. For people with A blood, they can only get blood from themselves and O. Same with B. B can only receive blood from themselves and O. But what about O? O, if somebody with O blood wants to transfuse to the other person, make sure that the other person would also have O blood. So if you are O blood but you receive blood from A, B, or AB, your body will fight it, because to your body, A, B antigens are foreign. Okay, so if you look at the blood type, a lot of people have O plus or O positive. And also you can see that A plus would also be the majority, 34%. The lesser number of people will be for the minus, or for the negative, O negative, A negative, B negative, and the most rare person will be AB minus. Usually they are just 1% of the population. So in China they call the AB minus blood as the panda blood. Usually because they are the only ones carrying that blood, the government actually keeps them alive, give them food, give them free houses, free food. Okay, um, for this reason, what happens that they actually need to give blood every week. Okay, because they are the living blood banks. Okay, so what does your blood type mean? A and B antigen are actually this protein that is on your red blood cell. Different red blood cells would have different surface proteins. So A would have only A, B would have B, AB would have both, O doesn't have anything. Other than that, the plus and minus is actually from the factor called the rhesus factor. If your blood contains the Rh protein, you are rhesus positive, Rh plus. If your blood doesn't have the Rh protein, you are called Rh negative. Okay, so the danger for rhesus types will be during pregnancy, where the mother and baby have differing Rh types. For the mother who are Rh minus carrying an Rh plus baby, it can actually cause problems, because the mother is plus, the child is minus. The mother's body would regard the baby's body as intruder, so the white blood cells would attack the baby's body. Usually, first pregnancy would have no problems, but after the first pregnancy, the immune system is sensitized, meaning that they would suddenly notice that there's an enemy inside. Okay, in second pregnancy, the mother's immune system would attack the body of the baby using the antibodies. Okay, so this is the blood compatibility. AB can receive blood from all, and can only give blood to AB because it has antigens A and B. A will only have antigen for A, but antibodies against B. So they can give blood to AB, but can receive blood only from A and O. Okay, B can only receive from the self and from O, but they can give blood to themselves and AB. For O can actually give blood to all, but they can only receive blood from themselves. So if blood is mismatched, as you can see in this blood test kit, usually what will happen is that the blood will clot. Clotting means that there is actually the protein that is within the host blood will attack or clump the red blood cells with each other together. So it will be clumped together, it will be agglutinated. So the first serum is called the NTA, and the second will be called NTB. If you have A, you will clump the blood. If you have B, for NTB, you will clump the blood. Okay, for type B contains antigen B. So for A, nothing happens. For B, suddenly it clumps. For A, you have antigen A, NTA will cause it to clump. NTB, no, because it doesn't have any B protein. What about type O? Type O has no antigens at all, so there will be no agglutination occurring. So people with O blood can just give the blood to A and B people, because they actually have no antigens. NTA will only attack A, NTB can only attack B, but O has nothing, so there's nothing to attack. Okay, that's the end. Now on to the next lesson.